Kia ora. Here's our fourth example. So again, you look as far up as you can in the mass spectra to get the molecular ion, and you see that there are two peaks there, a little peak over there and 2 units further down. So that's a clue for the chlorine, because it is in a 3:1 ratio. You can see the same thing over there. So molecular ion of 78, always take the lower one, not the higher one of 80, because the more abundant isotope is the 35, so it gives us a molar mass of 78. We can see some very distinctive strong peaks here in the fingerprint region, which supports it. And these could be the carbon that is attached to a chlorine. It is possible. So we know there's no nitrogen because the molecular ion is even, and we know it's not bromine because the ratio isn't 1:1. We know there's also no nitrogen as supporting evidence from the IR, because there are no peaks at around about 3,500 centimeters to the -1. And yes, this one over here in NMR could possibly be from nitrogen, but it's you would only be given one nitrogen, so you would expect an odd number in the mass spec. So again, alkyl, that matches up, and then we know very clearly that there is no alkene present because of the lack of peaks in the required areas. Spell out those areas you expect to see them. Again, we see there's no carbonyl, so all of these functional groups are absent, which is supported in the NMR. Spell out the area where you would expect to find those peaks. In terms of formula, it's 78. We subtract the mass of the more abundant isotope of 35, giving me a mass of 43 for carbons and hydrogens. If I divide that by the molar mass of carbon of 12, I get 3.58. So if I have 3 carbon atoms, that leaves me 7 for hydrogen, giving me a formula of C3H7Cl. So Cl is like C3H8 in terms of the formula. So in other words, CnH 2n plus 2, which means it is a saturated compound. And that is confirmed in our spectra because we don't see any double bonds. Kia ora.